Hey everybody, Mr. Judson here. So this is our last day of review. On Tuesday next week we have our Central Washington final. Don't forget, you need to send me an email, tell me what time you want to take it, and I will send that email to your parents. And they will proctor the test as you guys work on it. Real important, also remember you have 3 hours to return that to me. I'll send it to you guys. I'm giving you a little extra time. You know, typically we have 2 hours to work on this final exam, but I'm giving you guys a little bit of extra time to get it printed out, get yourself situated, get it scanned, and get it sent off. Make sure your printer's working. Make sure you got ink. Make sure you got paper. All that stuff is ready to go. Don't wait till the last second to check on that. Also, don't forget, and this is so important. I feel like some people still have it in their head that the Central Washington final is kind of like, you know, it really doesn't matter how I do, my grade can't go down. We're not trying to earn a Tacoma School District grade right now. We're trying to earn a Central Washington grade. And yes, your grade can go down. Central Washington doesn't operate under the same rules as Tacoma School District. So, you know, if somebody fails this exam and ends up with a failing grade for the semester, that's what you get at Central. Okay. Now I know we have a bit of a safety net here. We can use the emergency pass or emergency fail option, which we talked about on our Central Washington meeting. If you forgot about that, go back and read some of the stuff that I've posted on the Sway page. Okay. But you'll have 3 days after I grade it. I'll let you guys know what, hey, I'm done. Here's your score. If you don't like what you got as a grade, then you can contact Central and fill out their form. All right? So yesterday we were talking about this problem. I told you guys we'd come back and do it a different way. This was the ship that leaves port with a bearing of north 62 degrees east. And here's that right here. North, we rotate 62 degrees. It then went for 3 hours at 24 knots. I put it right here. And then it changed its bearing to south 80 degrees east. So here's south, rotate 80 degrees towards the east, and now go that way for 2 more hours. Okay? And so let me just write down the answers that we got in the corner here. 113.731, I'll just go NM for nautical miles, and the bearing was north 77.061 degrees east. So we're going to erase all this stuff and do this problem a different way with vectors, and then you guys can decide which way you think is easier. You know, the nice thing is during the Central Washington test, they won't tell you what to use. You can make up your own mind on that. All right, so let's see. I'm going to erase this right here. I guess I still need all that information. All right, so here's our final result. I think when we were working on this, I called this angle alpha, but I don't really feel like I need that anymore. Okay? So what we're trying to do is we're trying to figure out this vector in component form. I'm going to call this R for result. Okay? And what I need to do is I need to write down these 2 vectors. They're already head to tail, right? I need to write down these 2 vectors in component form. So I'm going to call this vector A, and I'll call this vector B. And remember, when you write down vectors in component form, what you have to do is you have to use the angle that's formed with the positive x-axis. So if this angle right here is 62 degrees, all right, 62 minus, or 90 minus 62, that's going to be 28 degrees for this angle right here. And so my vector in component form is going to be 72 cosine 28 comma 72 sine 28. That would give me the xy coordinate for this endpoint right here. And then for vector b, what you have to remember is it doesn't matter where this vector is drawn. You can move it anywhere you want as long as you don't change the length and the direction of it. So if I move this vector all the way down here, I could find the xy coordinates for that vector as well. But I can also find it up here for using my compass as an xy axis. So if this is 80 degrees right here, the angle with the positive x-axis would have to be a negative 10 degrees. Not just 10, because 10 goes in the positive direction. This is going in the negative direction. So I'm going to write down 48 cosine negative 10 degrees, comma 48 sine negative 10 degrees. There's my vectors in component form. And all I have to do is just add those up to get my resulting vector. So if I take my calculator, so remember, to add two vectors, you just add the x coordinates, add the y coordinates. So I'm going to take my calculator, and I'm going to go 72 cosine 28 plus 48 cosine negative 10. And what I got is 110.843. And I'm going to store that in the value x. So store x, enter. All right, now I need to get the y coordinate. So I'm just going to arrow up and hit enter where I've got 72 cosine 28 plus 48 cosine negative 10. I'll just go back and change the cosines to sines. So we'll change that to a sine, and I'll change the other one to a sine. I hit enter, and what I got was 25.467. And I'm going to store that in alpha y. So what we just figured out was the coordinates for this endpoint right here. When I add these two vectors together, this is the result that I get. And if I started here at the origin, I would come out 110.843 and then up 25.467 to get to that point right there. All right, so I stored this in y. Now I just have to figure out what the magnitude of vector r is. Remember, that's just the length. And you get that by doing the square root of x squared plus y squared. So this is how I'd show my work on the test. I would say the magnitude of vector r equals the square root of x squared plus y squared. I've already said what x and y are right here. So on my calculator, because they're stored in memory, I'm just going to do the square root of x squared plus alpha y squared. And what I got was 113.731. Look at that right there. And now I need the angle or the bearing of that. So theta is going to equal the inverse tangent of y over x. Remember, if I drew this triangle in, tangent is opposite over adjacent. So the y value over the x value. So second tangent of alpha y divided by x. And what I got was 12.939 degrees. Now that doesn't match this, but that's because I haven't written this as a bearing yet. Right? That's what we found was this angle right here. Okay, with the positive x-axis. So to actually get the bearing, So I start at north and rotate that way. I've got to do 90 minus this. So if I do 90 minus my last answer, I get 12.939. I get 77.061. That's what we have right there. So how far is the ship from port? 113.731 nautical miles at north 77.061 degrees east. There's my answer right there. Did I write a whole lot less? No, not necessarily. But I just like how easy it is to set these up, and you just add straight down and get a number, straight down, get a number. Square root of x squared plus y squared, you've got the magnitude. Inverse tangent of y over x, you've got an angle. You just got to make sure that you're giving that angle the right way. You know, if they're giving us angles with the positive x-axis, then we're done at this point. We don't have to do anything else with it. But if we're talking about ships or airplanes, then we got to think a little bit more to, you know, give the bearing the way they like to see it. All right. All right, so here's another problem involving vectors. Remember we said that a vector in component form, it means it starts at the origin and goes to this point. All right? So vector u is 3 comma negative 5, and vector v is negative 4 comma negative 3. And what we want to do is we want to try and find the magnitude of vector v minus 4 vector u. You guys go ahead and try it. So you could draw a picture of this if you wanted to, but I don't think you really have to. So vector v is a negative 4 comma negative 3 minus 4 times vector u. So if I do 4 times 3, that's going to be 12. 4 times a negative 5, that's going to be a negative 20. And when I do this, I just multiply by 4. I don't multiply by a negative 4. And the reason is this. If you multiply by a negative 4, then you're supposed to change this to addition because you already took care of the negative sign. But a lot of people forget to do that. They leave it as a negative sign, which means you're really doing that negative sign twice. So I just take that, write it down here, multiply this vector by 4, and now just subtract them. So a negative 4 minus 12, that's a negative 16. A negative 3 minus a negative 20, so that'd be a negative 3 plus 20. That would be 17. And now I need to find the magnitude. So this is our resulting vector. And so the magnitude of the resulting vector is just going to be the square root of a negative 16 squared plus 17 squared. I just need to go ahead and do that on my calculator. So let's see. So 16 squared, I'm just doing 16 because negative times a negative is positive, positive times a positive is positive. That needs to be a positive answer. Plus 17 squared. And what I get is the square root of 545. Now, if you just go ahead and do square root of that number and you get 23.345, that's fine unless they ask for an exact answer. If they ask for an exact answer, then you've got to make sure that you simplify this the way you're supposed to. So 545, let's see, if I divide that by 5, I get 109. So that's 5 times 109. 109, what can I divide that by? I think that's a prime number. I don't think that square root simplifies, so if they want an exact answer, then you need to say the magnitude of vector r is the square root of 545. Okay? If they don't say which answer to give, either one's fine. But if they want an exact answer, we need to make sure and give this one. All right, well, you guys, this is a pretty short video. So here's the thing. We haven't learned everything that we would normally learn during a spring semester of pre-calculus, but we've done a pretty decent job. I've covered enough things to get you guys through the Central Washington final. As long as you stayed up on the work and you understand what you're doing, you should be fine through that test. You'll be fine next year in calculus. If you haven't stayed up on things, that's a different story. I'm going to leave the videos on YouTube. I would maybe make an effort at trying to get through that during the summer. I think a lot of people have made some decisions during this pandemic time that probably aren't the best decisions. I know some people have told me, sorry Judson, I got caught up playing video games and I just lost track. And how do you play video games for 4 or 5 weeks straight? I don't know. I know you guys are going, oh, easy. But, hey, in life we've got responsibilities we have to take care of. We've got to make sure and do that. And so if you think you want to take calculus next year, you may want to go back and look at those videos. Of course, the people that need to hear this probably aren't watching right now. So anyway, here's what we have. C24. Page 483, we're going to do 45, 69, and 71. So this will be our last video that we have. It'll be the last time I talk to you guys through video. Everything else will be just through email. And so there we go. It's been different, it's been strange, but hopefully we've gotten some stuff done here. All right. You guys take care. If you haven't done it yet, make sure you send me an email. Tell me what time you want to take the test, either 10 a.m. or 6 p.m. on Tuesday. I believe that's June 16th. And we'll go from there. All right, take care, you guys. Stay safe.